In this video, we'll be covering trigonometric equations, and we're going to be looking at solving them graphically and also solve them using algebra. On your screen, you can see two equations. In the red, you can see 3 sine 2x, and in the blue, y equals 1. If I was told to find the solution for 3 sine 2x equals 1, that would be the intercept points where the blue and the red lines cross. Algebraic solutions involve solving a trigonometric equation by finding the angle that satisfies the equation. This method will be covered in more detail in the examples. Our first example involves solving it graphically. So we need to sketch y equals cos x plus 2 and y equals x. When drawing and sketching a trigonometric equation, remember we have y equals cos x. Let's write that a little neater. Y equals cos x plus 2. Our plus 2 here is our vertical translation, which means the center of our cos wave is going to be at 2 here. All right. So we'll be rotating around this point, this dotted red line. We know we start 1 up from that for a cos, so we're going to start at 3, and we're going to cross down here, reach this point at pi, and then back up. So our cos graph is going to look something like that. The next thing we need to do is draw our y equals x line, which you can see in blue now. If we were told to find the solution to cos x plus 2 equals x, we need to find our intersection point where they cross and then find the value there. So if we see our blue line crosses our cos wave around here, so it's approximately just slightly bigger than pi on 2 there. For cos x plus 2 equals 2, we need to draw a line at y equals 2, which happens to be our dotted red line, and we look for the cross points there. So we know for our cos x plus 2 equals x, x equals, I'm just going to approximately 7 pi on 12. Now if we do our next line, which was our cos x plus 2 equals 2, our x is going to equal pi on 2. That's where the first point is. I'll draw a line down there, and our second point is at 3 pi on 2. So you're looking for where your cos line or your trigonometric line crosses your second part of the equation. So in our case, it was y equals x or y equals 2. Alright, now we're going to solve this one algebraically. First thing I want to do is start to rearrange this. I want to form some sort of fraction on my right side. So I'm going to divide by 2, divide by 2. So sine 2x equals a half. If you use your exact values, you know that that is going to equal 30. So sine 2x equals 30 degrees. Our sine is also positive, so we know that we're looking at our first and second quadrants. Alright, therefore in our theta is going to equal 2x will equal 30. In the first, in the second, it's going to be 180 take away 30, so 150. Then we have to do another lap, all right, because we have 2x, it indicates that we're going to 720. So our next one will be 360 plus 30, and then 360 plus 150. So we're left with 30 degrees, 150 degrees, 390, and 510. Now remember, first, second, first, second. This section here is from 0 to 360, and this section here is our 360 to 720. Right? Now that we've got that, we can get rid of our 2 on this side, so we're going to divide everything by 2 to find what x equals. So x is going to equal 15, 75, 195, and 255. So these x values solve our solution for 2 sine 2x equals 1. Now remember, again, that 2 up here indicates that we're doing 2 laps around our circle, so you'll have to go from 0 to 360 and 360 to 720.